All right. It is 12:02. I can go ahead and get started. My name is Xavier Smith. I'm a computer engineering major on the electronic systems and communications track here at UMBC. I'm the lab director for the student branch here, and today we're going to be talking about 3D printing. I'll give a little overview, kind of about what that is, what additive manufacturing is, which is what 3D printing is. And then I'll give a little bit of my experiences because I brought my 3D printer to UMBC and my dad has one and we've been printing like things like crazy. So I can give some of my experiences, advice for, printing, how to make sure your prints come out the right way. And then, yeah. And then any questions anyone has, I can answer at the end. So we can get started. We're going to be talking about the what, when, who, how, and where and whys about 3D printing. I guess we can just jump right in. So what is 3D printing? It's a form of additive manufacturing that allows prints to that allows plastic to be melted in this in an extruder, and you're able to make 3D dimensional objects. So normally, what you would have is you have a software. Software would take that would take a file. It would dissect the information into G code, which are instructions for the 3D printer to take in, and then it would follow those instructions, melt the plastic, that's melt the plastic filament that would follow into the extruder, and then it would physically print the material. And so normally they're printed in thin layers. The thinner the layers are, the smoother the print is. Because normally when you buy like objects that aren't 3D printed, but that are created as one whole object, the the lines that are in between each 3D print should be small to make it look like a smoother print or make it look like it almost wasn't 3D printed. Um, So we can talk about a little bit about the origin of 3D printing, kind of where it came from, when it was invented. The first person that kind of stuck their head into the world of 3D printing was a Japanese inventor. His name was Dr. Kodama, if I didn't pronounce his name wrong. He created a form of additive manufacturing where he used an ultraviolet light to harden polymers and create solid objects. So that's a form of resin 3D printing. Same thing with stereolithography, and which is stereolithography is also it's similar to what Dr. Kodama did, uh, but he used but the people that created stereolithography, they used a laser, and that laser would harden either liquid or harden either liquid or different types of polymers, and it would follow the same instructions. It would break down the material into G code or instructions, and then it would harden the polymers with that laser. Same thing for the SLA machine or SLS machine, which is SLS stands for Selective Laser Sinistering technology, which is similar to stereolithography and almost kind of resin 3D printing. But it's layer by layer melting of a plastic powder, which is similar to resin 3D printing. So why should everyone care about 3D printing? Well, technically you can create anything with a 3D printer. And that's why it's very useful for people because especially for hobbyists, for I mean anyone, like most people, most hobbyists, people in industry and research, the power of being able to create anything, literally anything that your mind can think of, whether it be figurines, whether it be gear parts that can replace actual metal parts, because 3D metal printing is a thing. Whether you want to create glassware, or parts for your PC, anything, or even a phone case. Whether you're really into 3D printing, or maybe you just want to print something to make make your phone look cool. Anyone can use the power of 3D printing to kind of benefit their lives in any way. And it's used in all areas, whether it be professionally or through like hobbyists or lightly. Um, so how does it work? So I kind of went over it a little bit, but I'll go a little bit deeper into it. So normally the 3D printer takes in instructions in the form of what we call G code. And those G code, like I said earlier, were instructions. Instructions to where to place. Basically it's a coordinate system of where to place where to place the extruder, and where to let out filament and where to retract filament. Um, and so normally, so you can start by using a CAD software or computer aided design software. What that is a software to help create 3D dimensional objects, and it's a rendering software. So there's CAD softwares like Inventor. There's Inventor is more of a multi-purpose, more known software. There's NX, which is more industry related. Um, there is Fusion 360, which is from the same company as Inventor. Um, these are all some softwares that you can use to start from scratch, create any object that you want. And then after you create that 3D rendering of that object, what the next step to do would be convert that file to an STL file. That STL file is, those are instructions. It's a type of file that holds instructions, holds that G code inside, and then can be uploaded into a 3D printer, upload into the 3D printing software. And so the software, any software that which is the slicer software, it comes with that 3D printer. So my 3D printer is called Anycubic. It is Anycubic iMega Pro, and the slicer software that comes with that is the um, Alticura, I believe, Alticura Pro version 4.14. And so what I would do is you would import an SEO file, and then it would create that 3D rendering inside of that slicer software. After that, what you would do is, depending upon the different settings in the software, you can change the settings for your physical 3D printer. And what that means is that as you're like slicing or trying to figure out exactly where you want the 3D print to be physically be on your board, on your base, the temperature, you can change the temperature of the extruder, the layer height, you can change a lot of other things like retraction, meaning that when you're beginning to print on one part of an object, and the extrusion is moving between parts, you can increase retraction, which means that you can uh, uh, decrease the stringing between parts, which I'll talk about a little bit more later. Um, and then you can change uh, a lot of other settings that can help to make your print a lot smoother. And so after you go through and slice down your entire software, or slice down the entire like part, then you would press print, and then the information would be uploaded into the printer, and then the printer would go through and enact those instructions. And what you can see here is these are just coordinates. It just tells exactly where the printer to go, how much filament to extrude based off of, and then it'll give you an estimate time for how long it'll take depending upon the software. Um, so where can you print? You can buy your own 3D printer. That's where most people decide to get their own, or most people decide to get their own, and they just print at home, which is what I did. I got one for my friends and I. We split a 3D printer 3 ways, and it was about $300. So we spent $100 each, and I got it before school started. So when I was at home, I was printing all the time. I would find a print online, because there's which I'll talk about a little more later. Also, uh, there's a there's a website called Thingiverse and Things, where you can download STL files. So people can create their own 3D rendering objects and upload it to this website, where you can just download and print it without physically creating it in your software. And so that's what I was doing. So at home is a big one. Your local library, maker spaces are a big one. The UMBC Common Vision and IEEE Student Branch, We have two 3D printers in the lab, and you can grant access. We can grant you access. If you need something printed, you can send us the STL file, and then which you can find online, or if you want to make your own, converting it to an STL file and sending it to us, we can print that for you depending upon what colors you want, and what type of filament you want, and yeah. So, let's see. And why care about 3D printing? So specifically, I'll talk a little bit about metal 3D printing to kind of get this point across. Normally, when parts are printed for uh, the automotive industry, or not printed but created for the automotive industry, they're used solid materials. So whatever, whether it be like aluminum, uh, iron, different types of metals that are used, they're smelted and in a furnace, and they're casted to make these parts, that can, based off of specifications, and that process in itself, it takes a lot more money, and it takes a lot longer to make those. And so for specifically talking about like metal 3D printing, you can reprint, or and you can print the same parts without having to go through that process, of that the process of making, um, like the smelting process, the longer process that people have created when, that works. But you can create, and you can add on, and any like additives to, I guess, and for, I guess, different types of gears, um and making sure that they're sturdy enough. 3D printing, you can, to ensure that the to make sure that your parts are to make sure that your parts are sorry, yeah, to make sure that your parts can fit. You can, like I said, you can add on or change different things inside of your slicer software, which you can't really do as much with, your with other, additive manufacturing types. And so, another thing is more control over materials. So the thing that I can do with my 3D printer is I can print plastic. That's the main thing that you can print with plastic, with 3D printing. And it's called PLA, and I cannot remember what that stands for at the moment. But normally you have just regular types of PLA, and PLA is just different types of plastic, right? There's other types, like I said, metal. I bought wood filament, and so what that is, it's a wood PLA, which it's still plastic, but it has 30 or 40% of mixed with, it's about 60 or 70% plastic, but 30 or 40% has wood shards in it, or wood shavings, and so it gives that it's somewhat artificial, but if you print it the right way, you can get it, that wood feel, and the look that you could want, with like a wooden vase, or a wooden box or whatnot. And um and there's a whole bunch of other filaments that you can buy. There's glow in the dark filament, there's transparent filament, which I got some. There's a lot of other You have a lot of control over what your print will look like and what the colors you can look like. You can melt, um you can or mix filaments together. And so some 3D printers have dual extruders. So mine only has one extruder, and so that can only one color at a time. But the 3D printers that are a little bit more expensive, I think my dad has one of those. That has a dual extruder. It can print two colors at the same time, and you can make, without stopping your print. Because normally, if you have an extruder that has one 3D printer that has one extruder, then you would have to stop your print in the middle, and you can program it to stop at a certain layer, and then you would have to extract your filament and put it back in. And so that's how you would normally do it with one extruder, to make a either mixture of colors together, or make it where you can have multiple different colors in a single print, whether or not, like, maybe you're printing like a figurine of some sort. But with the dual extruder, and with you have more control over what your color will look like, and then the materials that you can put in, you can make, I mean, absolutely anything. Um, so like I said, so I kind of just talked a little bit about the materials. ABS normally is not used as much because ABS is a little bit more brittle nowadays. PLA is the standard, and TPE and TPU. Yeah, these names are getting past me. I cannot remember what they stand for, but I just know that, um, like based off of like experience, almost which ones are better. So PLA is the standard. ABS is not used as much because it's fading away. It's a little bit more brittle. TPE and TPU are the ones where you are the plastics that are a little bit more sturdy. And if you ever went to like IKEA before and like taken if you've seen like something like the plastic whether it be chairs or spoons or like bowls that they have there, if you get a really nice print from your 3D printer, your print will almost feel and look like those hard plastic um items. Nylon is one thing. Nylon is a rarer type of print and or rare type of material, and so you have to get a special 3D printer and then resin. So I'm I have a regular 3D printer, but I want to get a resin 3D printer. Those prints are resin 3D printers are, in my opinion, a lot better. You can get a lot smoother prints. Um, the challenge that I would have with my 3D printer would be just trying to get those layers small. Because if I can see the layers from a distance, I can tell that it's 3D printed. And my goal when I'm printing is to make it look like whatever I'm printing is not 3D printed. So it almost looks like I can create anything and no one would ever know that it's 3D printed. So if I use like rock PLA filament, which my dad got some of, like if I can create like a skeleton and it almost looked like I bought it from the store. Um, the challenge with that is that number one, it's not individual. The when you're printing with the regular printer, the printer or your print, whatever it is, it's not one piece. It's multiple pieces because it's taking the plastic and it's laying it down on top of each other. And depending upon how hot your bed temperature is and how hot your atmosphere is, whether or not your printer is closed or open, it'll stick to each top of the layer, and then it'll all be when it's all finished, everything will be, I guess, melted together. Um, but the sturdiness or the malleability of those prints vary from filament to filament. And so for resin 3D printers, your filament, quote unquote, is liquid. And so your that liquid you would pour it into the printer, and then you would use a laser, and that laser would melt almost like SLS printing, like I mentioned earlier. It would melt the filament, and it would create that almost like you see right here. This is what a resin 3D printer looks like, and it would melt the filament to create that object that you're looking for, but it's all one piece. And so it looks a lot cleaner and it looks a lot nicer. And so that's normally, although it is a little bit different, you do have your own issues, like all things. You have your own like challenges with the resin 3D printer. That's usually the the printer that personally that I go for. Um, so there's different methods of of printing. There's a Bowden extruder or direct drive and resin, which I already talked about. But Bowden extruders have, which are usually a little bit more common. What that is you have, which you can see right here on the right, a there's so the two motors, um, and so those motors are programmed to push the plastic filament through the tube, and it's usually a distance, a good amount of distance from your extruder. And so as it's pushing the filament through that plastic tube, your hot end or your extruder or your metal tip has to be hot enough to ensure that it can melt the plastic. And so the reason why your extruder kind of looks like a triangle is because it depending upon that sets the filament width or the diameter of how much filament comes out of that printer. And so that's like that quote unquote Bowden type tube. The direct drive, is a little the only difference between it is that the motor is inside of the extruder. And so the advantages and disadvantages you have with that is that here filament can get stuck inside the tube. If you're for whatever reason, if your filament has like a crick in it, or if it has or if it's like uneven inside of the plastic, then it can get caught, which then the bad thing with that is that you have to restart your print. Um, I mean, imagine a print takes 13 hours and then something happens inside of your plastic tube and then you have to reprint it. All that filament gets wasted and then all that time gets wasted as well and power. Uh, here, the direct extrusion hot end has like I said, the motor inside of the extruder. And so the I've never actually worked with this, but I know the advantage with this is that you don't have the um the possibility of having filament getting stuck in the tube, but you do have possibility of the filament getting stuck right here. That bridge right in between the motors and the nozzle. Um, and so Thingiverse, which I mentioned earlier, along with Things, which I can show you after this presentation is over, what that website looks like. Um, that is a community run website where people upload their STL files and you can just print anything. You search what you want to find, download the files, they show you what the print looks like, and then you can upload it to your software. Which is really cool. It's where you can get started, honestly, to just print, test your settings in your 3D printer to make sure your print looks good, and just get going. Um, so before I talk about next week, I kind of want to show you um what Thingiverse looks like. And so this is what Thingiverse looks like. It's um, basically it's just anything you want to print. So if I were to say, let's say like a vase, right? That's usually the most common one. Um, I actually printed this vase, and I think I have this one as well. Yeah, and my dad printed this one. Yeah, so you can what you would do. So if I were to click on this one, you would download the file. It would show you kind of this is their 3D rendering of what it would look like. This is what it looks like usually in your software, in your 3D printing software. And then you would download the files, which I would do. And then I will open up my software to show you guys a little bit about to show you kind of what it looks like and what like the slicer looks like. And then so yeah, you download the files. Just take a second. Open this, extract it. Yeah. And then normally at the bottom here, people would show you, you talk about like kind of their instructions for how they printed it, depending upon whether or not the print needs to be and printed quote unquote in a certain way. Normally, like this one doesn't have it, but some people would say, oh, it does actually. Yeah. So the layer height and the infill, which I can show you what that means in a second, um, to make sure that your print looks like what they printed. And so normally they'll show you what it looks like, what it should look like, and with their settings to make sure that you can get the same thing that they got. So this is what my software looks like. So I will upload with that. Spiral base looks like. And so this is what it looks like in that software. Like I said, this is Ultimaker Cura, and the printer that I have is Anycubic Mega Pro. This one has a laser engraver on it, which is pretty cool. But yeah, so the settings that I was talking about was the settings for the printer itself. Trying to figure out how can you get the best print. That was the biggest thing for me. When I first got the print, I just started printing, right? Then I'm like, how can I make the print nicer? Right? How can I make it look like it's not printed? And so I can quickly go through each of these, kind of what they mean, and then what happens when you slice that, and then what that looks like. Um, So the quality of your print is dependent upon like your layer height. So your layer height is the height of the print, the height, essentially height of each layer. And so once this is done slicing, I'll show you what that looks like. The height um of each individual layer and how many layers you have. And so normally you would want your layer height to be small. And the standard is 0.2 millimeters. And so if you want a nicer print, you can get a print of you can have it as 0.1 millimeters. And so that can it doubles the amount of layers that you have, but it decreases the amount of lines, quote unquote, that you can see. And you can see like this is crazy, right? 2 days, the settings that I have, right? And so if we press preview, um, we can see what that looks like. Um, and so this software is pretty cool because you can see how it's being built and where any issues may arise. And then the color scheme can tell you what's what. So the layer height it would be the height of each individual, whether it be the support, which is that blue thing, which I'll talk about in a few. But really, this layer height, which is the biggest thing here, it affects how small or how big each individual layer here is. And so you can see the cool things, you can see how it's being created. Which I find to be very, very useful to figure out, like I said, any issues that may arise in my prints because it's either a one or done. You can print, you can print, right? Just throw it in the printer and just print without like checking anything. But a lot of things that things that I run into is just wasted filament. I mean, because it costs money. Normally, filament, a good like 1 kilogram of filament costs like $24 off Amazon, some sort. But 1 kilogram isn't that bad. It's a good amount, but wasted filament is still wasted filament. So the however much you can minimize by using a software like this, where you can kind of see where your issues will arise is the best. The next thing are the walls. And so for this, which I'm gonna make this smaller slicer, doesn't take as long. Um, so the wall thickness is the thickness of your individual of your walls here, of basically of how of your outer wall. Um, that can give a sturdier print, and that's good for things that are going to go through a lot of pressure. Your top to bottom, and so what I'll do is I will pull this down a little bit. So you can see that the red corresponds to the shell, which is really just the outer wall. And so if I were to edit any settings here, that would edit the outer wall here. Um, the next setting here is a top to bottom setting. It basically it's how it's built from the inside out. If you have any prints on the inside, or if you have any filament that's being printed on the inside that doesn't count as a shell. So if I make this a little bigger, and I will change this to keep changes. Um, you can see the yellow there, which corresponds to that top to bottom. So that you can change how it's being built. So inside I have it being built like as lines here. So if I were to change this to a concentric build or a concentric build, then it would change, which you can see here. It changes. That means that the interior is gonna go in a circle versus going like lines and lines. So that's just your preference, depending upon how do you want it to be built, and how you want it to look. Um, Infill is depending that info is for a different it's a different setting. It's really just how sturdy your inside of your print is. So if you have a bigger print, maybe that has like say like a box, like a solid box, how sturdy is that in the inside? Like someone may ask you if they're using it for whatever reason. This is how you can change that. And so the density of somewhere around 25 to 30% is usually good. Depend for a normal print, and then upwards from that will increase the amount of filament used, but increase the sturdiness of the print. Um, So the material, and this is the biggest thing. A lot of people have issues with this. I have issues with this as well. I had issues until I figured out kind of the way to what to do here. Um, Plastic filament has a heating temperature. Like most things, all things have melting temperatures, right? And so the PLA, which I'm specifically be talking about PLA because that's the one that I use with this printer. PLA prints or melting temperature varies from 190 degrees Celsius to 240 degrees Celsius. And so if for whatever reason, if you have issues with your 3D printer not sticking, with 3D print not sticking, if you're getting like weird like prints, if you're getting the filament isn't coming out right, maybe you're having blobs and zits, maybe it's not you're getting for whatever reason, if you're not having the print that you're looking for, the first thing that I would do is check the printing temperature. So you can change each printer has their they have their limitations. And so my printer has a limitation of 260 degrees Celsius for the print for the extruder. And so I remember one time I was printing and my print just wasn't sticking. And so, I was wondering why, and it was the printing, it was the temperature. And so the temperature of the PLA was the minimum heating temperature was 210 degrees, and I had this at 190 degrees Celsius. So it wasn't getting hot enough. So that means that as soon as it was leaving that extruder, it was cooling instantly. And so it was just you could feel like it was just like the hardened plastic, but it wasn't like sticking on the bed. And so the next thing is the build plate temperature, which is the heating of the bed. So normally having it around, so I have it at an extreme, 100 degrees Celsius because I was printing a special print, but um, normally you want to have it around 60 to 70 degrees Celsius. What that does is that as soon as that printer comes down and it's printing, oh, as soon as the extruder comes down and it's printing each end of each like section, that part, it needs to have, you don't want it to cool immediately. The reason why is because if it cools immediately, then that plastic will like the issue that I had before, the plastic it'll form above the print, which I mean above the bed, which it won't stick to the bed. And so build plate adhesion is the biggest thing that a lot of people run into. And so people put different types of adhesives on the board, on the build or build plate, whether it be like glue, hairspray, um, some like my printer doesn't need it. It has a special coating on top of it. So as you're printing, and then eventually as time goes on, you would need to replace the build because the adhesive leaves or the coating leaves. But um, that's what you would normally do. Keep it around like 60 to 70. And if it's not sticking, what you would do is increase it. And so like I said, I increased mine 100 degrees Celsius because I was printing something special. But my advice is to read the temperature on the print on the filament to figure out what are the recommended um like temperatures for the build plate, and for your bed, and then for your extruder, and that will can mitigate a lot of issues that you may run into. Um,
Just a
speed is,
question.
oh yeah, go ahead.
Hey, so you mentioned a couple of weird issues you get regarding like the heat. Um, did is the heat of the like nozzle gonna? I keep getting these issues with like webbing across like where it has to go from like one pillar to another, and it leaves like a trail behind it.
Mhm.
Is that a temperature issue? Do you think?
Yeah, so you mean like stringing almost, right?
Yeah, yeah.
Yes. So yeah, so stringing is an issue. Yes, that is which I can actually jump to that
Well,
here.
if it's gonna like come up later, I was just wondering if that was a heat thing or if it was something else.
Well, no, so like that plays into both of these, like speed and travel.
Uh-huh.
So webbing or stringing, which is it's a great thing, which is still I still have issues with this because I'm like like basically what that is let's I will show you. If I were to import another base, if I were to say I want to import this vase, and let's say for whatever reason you're printing like multiple vases for your family, you're like and for yeah, multiple bases, and you want to print multiple at a time, because at that point, once you get your process down, you can begin to start just printing multiple of the same objects. Um, what's going to happen here is I'm going to let that slice. What's going to happen here is the extruder is going to move between these two parts, and it's going to print each part at the same time. The issue that you can have between each of these bases or whatever object you can have are stringing or webbing. What that is that is you're having you is it's a filament bridge in between each individual part. And so that's usually not good, because as that bridge or that stringing the string hardens in between the two parts, then you're gonna have issues. Like you don't you want the cleanest print possible. So um the temperature of your extruder is a big thing. The reason why is because if you have a max temperature uh for your PLA material, if your max temperature is 210 degrees and you set yours to 240 degrees, what's going to happen is that you're just like most things past its melting temperature, it becomes runny, and it almost becomes like a liquid with a lower viscosity. What that means is just it's yeah, it's a lot it's runnier. It can flow faster, and so when it's moving between print to print from this vase to that vase in this example, um, print the filament is still coming out of the extruder, and so it's going to come out in the air, and it's going to jump from this part to that part specifically, and then yeah, it's going to create that bridge. So no, so you want to have it in between its that the temperature in between its for example 190 210 degrees Celsius, 200 degrees or around 195 is normally the best for that, because you don't want it the filament to be runny, and so you're gonna have like a weird print. Retraction is another way you can solve that. Meaning retraction means at a layer change or between parts, it'll it'll take out or it'll retract or remove some of the filament as it's moving from nozzle from print to part to part. So imagine if you're going from this part and then it jumps to that part. What will happen is that the extruder, the filament will be extruded or taken in from the nozzle, and then it'll be extruded again as soon as it hits this part. And so how you like your distance and your speed can decrease the amount of string that you have. And same thing with your speed. Speed can increase your print quality, but can also increase the stringing in between parts. The faster that you do it, usually the better. Um, meaning that yeah, the faster you do it, the better, meaning that you have less time for the filament to come out between parts, and you also get a nicer print. You also get a nicer print in between each part, but the only downside is that as you increase the print speed, your print quality decreases because it's not taking a lot of time to lay down the filament. So you have to kind of mitigate between your printer and whatever part you're printing. You have to find out what the best settings are for that. Um, Besides this, and the last thing I'll talk about, which is just because the rest of these are just special. Build plate adhesion is another really, really big thing. The reason why is because let's say you want to print like an Eiffel Tower, or let's say for whatever reason, if I want to um, rotate this sideways. Let's say for whatever reason I want to rotate that sideways, and I were to slice that. An issue that you might be able to see is that this is above the build plate, which means that as it's printing, which the printer doesn't, the 3D printer just takes the instruction that you give it, just like a computer does. It can't tell the difference between what's a good and a bad print. And so this is where our own intuition has to come in to figure out where should I put in what we're calling build plate adhesion or support, or build plate adhesion and support, which are the two things I'm talking about. So um, the print is in the air, and so as it's going to print, as it's printing, that first print that first layer that you can see right here will be completely in the air, which means that because it has nothing to support it, it'll begin to bend over as it's cooling, depending upon your temperature and speed, your atmosphere, whether or not your printer is open or not. It keeps the temperature in or cools it. This part of the vase right here will be very deformed, and so we don't want that. We want our print to be the way that we want it, right? And so this is where support and build plate adhesion comes in. So if I were to press generate support and reslice it, what you'll see is that the blue um filament that or the blue like part of the uh, uh, print comes in. So this is a tree support structure. What that is that it basically it prints what it'll do, it'll print the support first. Um, yeah, so it'll print the support first, and then it'll print the print. And so how it'll do that is it'll make sure that as it's laying down each part, the part of the vase in this case, it will lay it over top of it. So as soon as the filament it gets cooled, it doesn't deform in the air, and so you don't get like a weird print, where it's like a weird a print that has like a dent or a dive in it. And that's normally where you so tree filaments are I mean, so tree supports are the strongest ones. You can change it to a normal. So it'll just print as like a normal support, almost like you're printing like another object. It's not really special. So this one looks, but it has a lot more filament on the inside. And so the only downside with this is that you're using more filament, and the another downside is how you're gonna get this out, right? I mean, like it's almost like once you print this, although, yeah, you have, like, a nice print and everything, and it looks it stays and nothing is deformed, but the question is, like, how are you gonna get this filament out, right? And I wouldn't know how to do that without breaking the vase. So, that's another thing that you have to kinda figure out, how can I do this the right way? So, if this were me, although the tree support structure is a lot harder to remove, I won't have to worry about taking all of that out, which you can see it only prints that tree part only on this part, only on the inside. So I can easily remove that with my fingers versus the other normal support, which takes a lot more effort. The last thing is build plate adhesion. For whatever reason, another way that you can make sure that your print sticks is through um, like I said, build plate adhesion. So what that is basically it prints filament from the outside of your um whatever in this case the vase or whatever object you're printing. And then what it'll do is then it'll oh, is someone unmuted? Oh, okay. Uh well, okay, so let's see, let's do brim. So to increase the amount of the to or to make sure that your print sticks, what you can do is you can add a brim or a skirt. What it'll do is it'll print this. It's basically just it creates more surface area. So the more surface area you have for whatever print that you're having, the better that it'll stick to your to the build or to your build plate. So it'll print this first. And so the cool thing about this is that if you have any issues for whatever reason with your extruder, it'll get rid of those issues before it hits the print, which I found to be very useful. So I usually always print with a brim. So let's say the temperature isn't the right way, right? Or let's say you have like a clog in it, I can pause it before it hits this print, so I don't have to restart the print, which means I have to reheat my bed. I have to um whatever material has been wasted for whatever reason, I can find that issue before it hits the actual build. So I'm like, okay,
Yeah,
I need
I
to
think
maybe
that's
change
actually
this to that.
cool.
Um, and so Bram is usually the best. A raft is extreme. Usually, a
Yeah,
raft is just this huge like
I imagine it's
um
really just massive.
build. Also, someone is unmuted. Someone else is
Yeah,
muted.
you can see it. Really long, long.
Um, could you mute your mic if you could? Yeah, thanks. Okay, so yes, the raft. Like I said, the raft is a stream. But it's just a huge, like, thick piece of material. Like, for whatever if your print just won't stick whatsoever, then I would recommend just going with the raft. It's a lot of filament, that's for sure. It's the downside because it's like it's just in the layers are thick, and so it's just like brute force almost. And so you can increase your raft, like your size for your brim and your raft or whatnot. And then my dad, I remember, used this for he printed a Snoopy, like a figurine of Snoopy, and so he printed it upside down with support. But the reason why he used the raft was because it just wouldn't stick. Like no matter what, it was such a bigger print and it was top heavy. That's the reason why he printed it upside down. And he uses the raft. He used the raft to mitigate the weight of that of the head of the Snoopy. And so um, that's what this is for normal prints like this. I wouldn't recommend it. But if you're having issues, like raft is usually the last uh like the thing that I would use at the end if nothing else is working. Um, but yeah, that's pretty much it. But once you go and you print, I don't have my 3D printer on at the moment, but if I were to just go through and print it, it would tell me the like here, it would tell me like the temperature of my print. I can change the temperature, and then I would go and I'll just wait for it to print, and then after that, I mean, possibilities are endless. Usually, the issues, the things that I would recommend doing is just buying filament. Whatever you want to print, buy filament, tester filament, and just try to see, figure out your settings, figure out your environment because that's another big thing. Just if your printer is an open printer, make sure you keep the temperature in your room or wherever your 3D printer is in a like keep it constant because otherwise, which is an issue I had. I remember I had my fan on and I went to sleep and I was printing something and I woke up and the although there's nothing wrong with any of my settings, the temperature in the room was increasing and decreasing because the heat was on, but the fan was also on. Heat was on in the house, the fan was on. So the two temperatures were combating with each other, and it was cooling the print. It was cooling the filament as it was coming out. Um, Instead of cooling it like maybe 30-20 seconds after it came, which and it was cooling immediately. So it was cooling it as soon as it came out of the extruder, which it wasn't sticking, which I woke up to a completely like 13-hour print just destroyed essentially. So that's also filament wasted, which means that's money wasted. Um, so yeah, I would buy like a huge roll of filament, 1 kilogram, 25, $4. Just test out settings before you buy the filament that you want to really use. So whether, like I said, whether it be wood, um, rock filament, I mean, they have all types now. You can just find on Amazon. And then like transparent, you could do metal 3D printers are a lot more expensive. But yeah, um, but yeah, that's pretty much it. Our next GBM will be next Monday, and attendance. I did want to make sure everyone he got here. Um, the general chat, and I'm going to paste the attendance in here. And if you attended, if you could just yeah, fill out that form for us so we know who came. And yeah, if anyone has any questions, let me know.
I have a couple of questions.
Yeah, yeah, of course.
So the first one is that do I have to be a major in electrical engineering to be part of this organization or
Oh, actually, no, you don't. You just have to be interested. That's
oh,
the yeah.
okay. Um Also, a lot of I've looked up like STL files for like the stuff that I'd want to print. I don't have a 3D printer right now, but a lot of it costs like $12. Like, can you like get around that by searching on Thingiverse?
Yes. So normally, what I would say, never pay for STL for print. Like never, ever. There's no reason why you should ever have to pay for a print. And I'll show you another website. It's called things.com. And literally, just this pulls from Thingiverse also, but like you can find absolutely anything on this one like online. You shouldn't really have to pay for STL files. The people that sell them are usually like the people who are the people who create like these extremely like intricate like prints in the 3D rendering software, which they think is valuable, but I'm pretty sure you could either find something similar to that, or you could even make your own without having to pay for it. So yeah, Things and Thingiverse are the two that I would recommend going to.
Also, also, if we wanna, just for also for attendance reasons, if we just fill out that form that you sent on the Discord, we'll get counted. Well, I guess we'll get credit for this.
Oh yeah, yeah. We just wanted to see who came um to the so we just for like yeah, just for retention.
Okay. And if we wanted to send you an STL file that we have so that you could print it, like, does that cost money, or how does that work exactly?
That's a good question. I'm not sure how we're gonna do that in terms of because I that's a good question. I can get back to you on that, and I we can make an announcement based off of if for anyone who attended or who wants to get 3D printed, whether or not they have to pay for it or not. I'm not completely sure, but I will get back to you, and
Okay.
we'll make an announcement so you can so we'll answer that question.
All right. Thanks for asking my questions.
Yeah, yeah, of course. Does anyone else have any questions before we wrap up? Oh, I can also check the chat. If no one else has any questions, I guess we can end it there. I hope this GBM was enjoyable. Um, if you have any questions, feel free to contact us, any of us, any of the core five members in the Discord, um, and or just ask a question in the general chat for in the Discord. Next week we're gonna have our next week is another GVM at 12, and yeah, I hope you guys have a great day, and that's pretty much it.